Yes. Okay. Good morning, everyone. And let me begin today's class with an introduction to properties of the system. Okay. So whatever that we had discussed there. Okay. So the first property was the linear property. I have already posted the video of linear property. How did we write it? And x of t. So taking the Fourier series of it. So you will be having x of k there. That is the complex Fourier coefficients. Next, y of t, if you take it, you will be having its complex Fourier coefficients as y of k. Okay, so y of t and y of k. Okay, so that is where you will be having it. All right, so now I have a z of t that would be equal to a into x of t plus b into y of t. Okay, so then z of t, its Fourier series representation. Okay, so if I take the Fourier series, hope it is visible. I'm sorry, I haven't shared. Sorry. Yes, I hope this is visible to you now. The screen is visible. Yes. So now I have z of t. How I can write z of t here with respect to the linear property? So you have two signals, that is x of t and y of t, along with the coefficients a of x of t into b into y of t. All right. So now I can say that to perform the linearity property, so x of t and y of t, okay, so both x of t and y of t would have the same fundamental period. Okay, so I'll write it here, x of t and y of t, in order to perform the linearity property with respect to the Fourier series. Okay, so the heading that what we are dealing here is properties of Fourier series. Okay, so properties of Fourier series. Fine. So now I have this Fourier series being applied on certain signals there. So you need to have the fundamental time period of both x of t and y of t to be, that is t, that is 2 pi divided by omega naught. Okay, so I can write omega naught as 2 pi divided by t. All right, so I have this angular frequency, okay, omega naught, that is angular fundamental frequency to be omega naught. So I can write this as 2 pi divided by t, and the fundamental time period, okay, the fundamental time period of both, that is x of t and y of t, are assumed to the same fundamental period there. All right, so that is what you need to remember while doing this Fourier series. Okay, so now how you can write z of k? Okay, so the proof of it is 1 divided by t integral over the time period z of t e power minus j into k omega naught into t. Okay, so z of t can be written as a into x of t plus b into y of t. I'll replace it here. I'll be having e power minus j into k omega naught t as the exponential value there. So I can substitute it inside, and I'll be having z of k being written as a into x of k plus b into y of k, where x of k and y of k, okay, so x of k and y of k are said to be the Fourier coefficients of the periods, that is x of t and y of t. Okay, is it clear to you, all of you? Okay, so this is nothing but the linearity property of the Fourier series. Okay, I've already sent the video, recorded video. How did we get this? I'm just going through it. So next one is the time shifting or the time translation property, which is there. All right, so I have x of t, which is under the Fourier series. So this is always, I can write it as let x of t, when I take the Fourier series, I'll be getting x of k. Okay, so this signal, once you have been shifted with t naught, okay, so t naught is the shift that you are doing here, so it is a delayed signal. In the same way, you will be having the advanced signal also. Okay, so z of t, that would be equal to x of t minus t naught. So it's z of k. Okay, after taking the Fourier series, what you will be getting? Z of k, that would be equal to e power minus j into k into omega naught into t naught. Okay, so t is being replaced by t naught into x of k. So z of t, that would be x of t minus t naught. So if you take its Fourier series, that would be z of k. So that would be equal to e power minus j into k into omega naught into t naught. Okay, so this is where you need to observe. This is the multiplication property that is associated with respect to x of k once you have the time shifting being done. Okay, so now let us go for the proof here. So x z of t I can replace with x of t minus t naught. Let me replace this by one single variable, that is t minus t naught would be equal to lambda. So t will be equal to lambda plus t naught. So what I can do here, so I have this t being written as a variable which needs to be supported there. Okay, so this is 1 divided by t integral over the time period x of lambda e power minus j into k into omega naught. So t is being replaced as t naught plus lambda. Okay, so that is how I can replace it, and this entire term is called as x of k. So here I have a new variable that is present there, and that's the reason why I can call this to be x of k. All right, so z of k that would be equal to e power minus j into k omega naught into t naught. Okay, so that is for the z of t which is shifted by x of t minus t naught. Okay, so x of t minus t naught there. Okay, now so z of t that would be for x of t plus t naught. Okay, so x of t plus t naught, what you can do, x of t plus t naught, so t naught value is here minus 3. Okay, so that is where the for, okay, for x of t plus t naught, that is there, where I can get it as z of k that would be equal to e power j into k into omega naught into t naught. So this minus sign would be changed to plus sign and it is multiplied with x of k here. So z of k that would be equal to e power j into k into omega naught into t naught. So that I can replace it like this. Okay, so next what do I have here? I have the frequency shift there. Okay, so one thing what we were discussed in the previous one, that was the time shifting. Okay, so this one, the third property that we are going to discuss is the frequency shift there, which is z of t that would be equal to e power j into k naught into omega naught into t into x of t. Okay, so I have a frequency shift where in the complex Fourier coefficient there. So once I have z of k that will be equal to x of k minus k naught. Okay, so once I have a shift in the Fourier coefficients, the complex Fourier coefficients, that is x of k minus k naught, what is the shift that you can expect there in z of t? That would be e power j into k naught into omega naught into t into x of t. Okay, so z of t is being replaced here. If you can observe here, I know that z of t will be having e power j into k naught into omega naught into t into x of t there. Okay, so that is where you can observe. All right, so you can have z of t, this one, that is e power j into k naught into omega naught into t into x of t. All right, so this is there as one more signal, and x of t is said to be a signal there, continuous time periodic signal. Okay, so z of t, next z of k. Okay, so that is having a frequency shift of k minus k naught. So this is the k naught value and this is the shift there, that is x of k minus k naught there. All right, so that is where you need to observe certain things properly. Okay, so if z of t will be equal to e power j into k naught into omega naught into t into x of t, z of k is written as x of k minus k naught there. Okay, so the proof follows in a similar note there. I have k minus k naught. Okay, so this value which has been written as x of k minus k naught, simple substitution, and you will be getting the frequency shift there. Okay, so all these properties are quite straight, and next one, it's again a scaling property. Okay, so again you have x of t to be having Fourier series of x of k, then z of t that would be equal to, okay, so x of at. Okay, x of at, next by taking its Fourier series, what you will be getting, that is z of k that will be equal to x of k. Okay, z of k that would be equal to x of k and a greater than 0, and a greater than 0 there. Okay, so z of t that would be equal to x into a of t. So you will be having Fourier series. Okay, so if you take the Fourier series, what you are going to get, so z of k will be equal to x of k. But I'll be showing you how did I take this. Okay, so when it comes to the change in the total time period, okay, so whatever the integral that we were evaluating, so it will be changed from integral t by a. Okay, so this is the change what you can observe there, and I'll tell you over the derivation how did I do it. Okay, so coming to the proof, x of t, okay, so x of t is periodic, x of t is periodic, x of t is periodic, then z of t, that would be equal to x of at, is also periodic, is also periodic. Okay, so x of z of t, that would be equal to x of at, is also periodic. Okay, so now its fundamental period, okay, its fundamental period, that is x of t's fundamental period is t, then z of t will have a fundamental period of t by a. Okay, so its fundamental period, that is t by a. So x of t is periodic, its fundamental period is t, and z of t, which is x of at, will have the fundamental period as t by a. Okay, so you are going to have the frequency that would be equal to omega naught in case of x of t, and this one, the frequency will be a into omega naught. Okay, so observe this carefully. How did I write it? So if I have x of t to be a periodic signal, its fundamental period would be t and its frequency would be omega naught, right? So how did I write this? Omega naught, that would be equal to 2 pi divided by t. Okay, so this will be the fundamental time period for t, and omega naught is the, like, the frequency there, the angular frequency that is there. Okay, so now z of t will have a fundamental time period of t by a, and its frequency will be multiplied there. Okay, so if you replace t with t by a, okay, so what you are going to get, omega naught, okay, omega naught dash, okay, I can say that as omega naught dash, that is 2 pi divided by t by a is the fundamental time period of z of t. Okay, so what you are going to get, a into 2 pi divided by t. Okay, so this 2 pi divided by t is omega naught there. So this new value of the frequency, that is omega naught dash, that would be having a into omega naught. Okay, so that is where you are going to get that. Okay, so these are certain basic things that you need to remember. All right, so now moving on to the next one. Okay, so moving on to the proof, how did I get this? I have x of k, that would be equal to 1 divided by t integral t, okay, x of t e power minus j into k omega naught t dt. Okay, so now this thing, that is the time period, is being changed from 1 divided by t by a. Okay, 1 divided by t by a integral t by a there. Okay, so that is z of t multiplied with e power minus j k. This omega naught is being replaced as a into omega naught into t dt. Okay, so what I can do here is I can have a divided by t integral t by a z of t e power minus j into k a into omega naught t dt. Okay, so that is where you are going to replace it. So now this z of t, what I can replace here with, again, this is z of t. What is z of t there? Z of t, that would be x of at. Okay, so x of at. All right, so e power minus j into k a omega naught t dt. Okay, so that is where you can write it. So at, okay, so this one can be replaced by one single variable again, that is lambda. Okay, differentiated with both the sides. Okay, differentiated both the sides there. So what you are going to get, you are going to get dt, that would be equal to d lambda. Okay, so I can write it as 1 by a here. All right, so dt, so this one has to be replaced, and this one, which is with respect to a variable, that is I have taken it as lambda. Okay, so a, that would be integral t divided by a x of lambda. Okay, this is x of lambda e power minus j into k into a omega naught t this dt is replaced by 1 divided by a d lambda. Get this? Okay. So what needs to be changed there? So I can have a, this one will get cancelled. It would be integral t by a x of lambda omega naught into t. So this a into omega naught might be taken as omega dash also, and we will be getting the equation as x of k. Okay, so x of k as the thing there. So the Fourier coefficients, okay, so of both the things, that is x of t and x of at would be identical. So few observations here, x of t and x of at's, okay. So Fourier series or Fourier coefficients, whatever that you are going to take, are identical. Okay, so are said to be identical. So second thing what you are going to observe here is you are going to have the spacing of harmonics, spacing of harmonics, spacing of harmonics, that is replaced with omega naught to a into omega naught. Okay, so that is where you are going to get it. The spacing changes from omega naught to a into omega naught. Okay, so that is where you are going to remember this. Moving on to the next one, okay, that is the time differentiation. Okay, so now once you come across time differentiation, okay, so again let x of t will be having the Fourier series, that is x of k, that is there. So now once when I take the time differentiation, so what do I need to do? It would be d by dt of x of t. Okay, so once I take the differentiation of x of t, that is the continuous time periodic signal. Okay, so you are taking the Fourier series, that is j into k omega naught into x of k. Okay, so this is the term that you need to multiply, j into k into omega naught into x of k. Okay, so that is where you are going to get this, where you have a general Fourier series representation as x of k, and you have d by dt once you take the time differentiation of it. So you will be getting j into k into omega naught into x of k. So let us proceed with the proof here. So x of t, how can I write x of t there? Can anyone tell me how can I write x of t? Simple proof. This is one simple proof there. So how can I write x of t, the periodic signal in case of summation? Yes, anyone who can unmute themselves and they can answer.
Sir,
Yes.
sir, sigma k is equal to minus infinity to infinity. X
Yes.
of k into
Yes.
e power j k omega naught t.
Very good, very good. E power jk into omega naught into t. Okay. So now, what do I need to get to do the like differentiation? I need to get this one d by dt of x of t. So to this equation, what can I do? I'll be differentiating with respect to time. D by dt of x of t. Okay. So let's differentiate. What do I need to do? I need to differentiate this one. Okay. So this is the sigma summation that is already there, minus infinity to plus infinity x of k e power at d by dt of e power at. So what is it? What is d by dt of e power at? Can I write it like this? Okay, that is a into e power at. Okay, so that is this entire term is taken as a, that is j into k into omega naught, okay, into e power j into k into omega naught into t. Okay, so that is where you will be getting here. Okay, so what I can do here is, so I'll be having the entire term in the brackets. So you can write it as j into k into omega naught into x of k. Okay, simple proof there. That is d by dt of x of t. So this is one more property, okay, with respect to the time differentiation. So second property what we had covered today, one is with respect to the scaling, and the second property what we covered today is with respect to the time differentiation. Okay, so what I can do here is I'll be stopping here. Okay, so meanwhile I'll share this video. All right, so I'll be covering few more topics and I'll be sharing it. Okay, so see to it that you are going to have few more properties which I can discuss. We are having the time domain convolution and multiplication theorem, and also Parseval's theorem, which I am going to discuss at 11. Okay, so why don't you go through it? I'll give a minute to you. Okay, so go through the topics, whatever the like the properties that we had discussed till now. So I'll be winding up with this d by dt of x of t, that would be equal to j into k into omega naught into x of k. Okay, so I can write it like this. All right, so that is the time differentiation property. Okay, so what I'm going to do now is I'm going to see to it that you guys go through it. Okay, once again you go through all the properties that are being available. Okay, so I'll give a minute or two to go through it and see to it that you can understand whatever the properties that has been discussed here. Okay, so after that I'll be going again with the numerical problems, and I'll be dealing these properties, how I can apply it to certain numerical problems there. Okay, can you start with the problems? Just anyone can confirm, and we can start with the numerical problems.
So,
Okay, then, okay. Yes. So meanwhile, let me start with the numerical problems here, and frequency 1 minute. Continuous time Fourier series. 1 minute. Okay. 1 minute. Let me. I'm checking the problem. Which one to go for as the first problem? Okay, so let's begin with one simple problem here. Okay, so make a note of it. Find the Fourier series coefficients. I'll write it as Fs for Fourier series coefficients for the periodic signal x of t with period 2 given by with period 2 given by x of t equals e power minus t, x of t that would be equal to e power minus t for minus 1 t to plus 1. Okay. Yes. Okay. So x of t that would be equal to with a period that is minus 1 to plus 1. Okay. So I have a graph here. So I'll be having 1 and minus 1 and this is 0. So the time period here is 2. This is plus 2 here. I'm sorry. You'll be having no negative values of time period generally. So you'll be having the time period that would be equal to 2 there. Okay. So once I give the value of t to be equal to minus 1, so it would be exponentially rising there. Okay. So you are going to have the symmetric nature of it. The symmetric is obtained with respect to the function over there. Okay. So e power 0. So you'll be having e power 0 as 1. Okay. This would be 1 here. All right. So you will be having at t is equal to 1. Okay. So at t is equal to 1, at t is equal to 2. Okay. So you will be having such functions there. Okay. So it is exponentially decaying. So this function over here like this. All right. So now it would be exponentially increasing there. Okay. So that is with respect to the other one. Okay. So what you are going to do here is you are going to have the exponential like this, and this one would be exponentially increasing like this. That would be like symmetric, which you can apply there. So e power minus t is a symmetric nature with respect to the vertical axis. So now I need to identify the Fourier series coefficients for the periodic signal, say x of t with period 2, and x of t is given as e power minus t for the time period that would be from minus 1 to plus 1. Okay. So now I have the solution as for the fundamental time period t that would be equal to 2 fundamental time period. Okay. So that is there. Fine. So now I have the fundamental time period t that would be equal to 2 omega naught that would be equal to 2 pi divided by t. So that is with respect to t that will be 2 and omega naught is taken as pi. X of k, what is the complex Fourier coefficient? How I can write it? I can write it as 1 divided by t integral over the time period x of t into e power minus j into k into omega naught into t dt. Okay, so x of t, this function is replaced as e power minus t. Okay, the time period that is 1 by 2. Okay, so I have to integrate it from minus 1 to plus 1. Okay, so that is the time period minus 1 to plus 1. Okay, so x of t is e power minus t, and this k, what is omega naught? That is pi into t dt. Okay, I have made the substitution that is for x of k in the given problem. Okay, so I have made a substitution for it. Okay, so that is where you are going to make the substitution for x of k that would be equal to 1 by 2 integral minus 1 to 1 e power minus t into e power minus j into k into pi into t. Okay, so now in both the terms you can take e power minus t as a common factor. That what you can write x of k that would be equal to 1 divided by 2 integral minus 1 to 1, that is e power minus t taken as a common factor. Okay, so that is 1 plus j into k into pi. Okay, so with respect to dt. Okay, so now can you evaluate the limits? From here on, it is with respect to mathematics only. Okay, so can you evaluate the limits and tell me the answer quickly? I'll write it here again. X of k that would be equal to 1 divided by 2 integral minus 1 to plus 1 e power minus t into e power minus j into k into pi into t, that is dt. Okay, so now can you quickly evaluate the limits there and get me the value of this integral in terms of yeah, you're going to replace it for t there. Remember one thing, you're going to replace it for t. Yes, can anyone solve it quickly and tell me the answer? Yes. Yes, can anyone tell me quickly? Yes, solve the given integral. And Sharan, are you there in the meeting?
Yes, sir.
Yeah, can you evaluate this integral?
Yes, sir. Doing, sir.
Yeah. Austin is there in the meeting? Shamant, are you there in the meeting?
Yes, sir.
Okay, evaluate the integral and do let me know the answer quickly.
Sir, minus
Okay.
1 by 2 into 1 plus j k pi into e power minus 1 plus j k pi minus 1 plus j k pi. I mean minus e power 1 plus j k pi.
So you have evaluated this one, right? Which is 1 by 2 e power minus 1. Okay. So e power minus t, I have taken it as a common factor. Okay. So e power minus. Okay. In the brackets, you have 1 plus j into k pi into t. Okay. So that is e power minus at you have to integrate. Okay. So what you are going to get if you integrate e power at? Okay, you are going to get, so if it is e power minus 80, that would be e power minus 80 divided by minus a. Okay, that is nothing but minus 1 by a into e power minus 80. That is what you are going to get there, right? So you are going to get 1 divided by a value, whatever the value that is there, that is 1 plus j into k pi, and you are going to have e power minus, okay, the same value, that is 1 plus j into k into pi, okay, into t. The value of limits is being evaluated from plus 1 to minus 1. Okay, so if I want to evaluate this limits, what I'm going to do, I'm going to have e power minus 1 plus j into k pi. Okay, a t value would be equal to 1 itself. I've taken it, minus e power minus, that is there, I can write it as minus 1 plus j into k pi. Okay, so this minus 1 which is there, I'll be multiplying with plus 1 here. So this will be 1 itself. So minus 1 minus into minus, that would be equal to plus.
Excuse me, sir.
Okay, sorry, yeah, tell me.
Sir, your
Sir,
screen is
answer
not
is
visible, sir.
sin 1 plus jk pi. Sir, cos 1 plus jk pi.
How it is sine 1 plus jk pi? How did you write it?
Sir, cos 1 plus jk pi by, sir, it's look like e power
Hmm.
1 plus jk pi plus e power minus 1 minus jk pi divided by 1 plus jk pi.
Yes. So see here, I'll come to the steps there. So you'll be having e power minus 1 and e power 1 here. Okay.
Sir, your
Hope you are
screen is
getting.
not visible, sir.
Oh, I'm sorry. I'm sorry. I've stopped sharing. That's a moment. Okay. Yes. I hope it is visible now. Okay. So now see here, it is e power minus 1 plus j into k into pi. Correct? And you will be having minus e power 1 plus j into k pi divided by 1 plus j into k pi. Hope it is correct. And I have 2 also here. I have evaluated the limits and I have got this one as for x of k. All right. I hope this is clear to you. ಅರ್ಥ ಆಗ್ತದೆಯಾ? Okay. Next, what needs to be done here is, so you need to have this function which is e power minus 1 and e power 1. Okay. So let me change it. Okay. So e power 1. Okay. So e power 1, e power minus 1, sorry, minus e power 1. Okay. So that is where you are going to have this e power j into k into pi with a negative sign. Okay. So now what you are going to do there, you are going to have cos k pi. Okay. So cos k pi plus j sin pi. Okay. With a negative sign. I hope it is clear now. Are you getting my point? Or else I'll give you time. Okay. Solve it by this 20 minutes time that you are there, and we'll have the same discussion in the next class. We'll start from here. Okay. So I want everyone to solve this, and you can get the solution quite easily. Okay. I'll stop presenting now, and you will be getting the solutions easily. Okay. So see to it that